Okay, folks, so 30, 60, 90 triangles often involve square root signs. So our skills with radicals, sometimes they're called, is very important. Let's write those words that I just said on the screen here real quick. So square root, okay. What does that symbol look like? That looks like, this sign. Sometimes it's called a radical. All right. So sometimes it's called a radical. Now, sometimes the number that is underneath the radical is a perfect square. So let me give you an example of that, like 25. Well, the square root of 25 simplifies to 5 because the square root sign means what times itself equals that number right there. So sometimes they simplify to something super easy, and it ends up being what's called a rational number. 5 is exactly 5. Sometimes they don't end up being rational numbers. Like, let's say we had the square root of 24. Okay, square root of 24 does not simplify down to a whole number. It's got to be a perfect square under here in order to give us a whole number. So what is it approximately? It's going to be a little bit less than 5, right? Like 4 point something or other. So if we want an approximation, we got to pull out our calculator. Now, most of the stuff we're doing, they don't want an approximation. They want it as an exact answer. So the square root of 24 could be written as something like the square root of 4 times the square root of 6. So what I try to do is I try to find factors of 24, and one of them is a perfect square. So, the square root of 4 then becomes 2. So I could write this guy as a rational number, but I don't know what the square root of 6 is. And so I've got to leave it alone. So I put down 2 square root of 6. This is an example of simplifying this radical. Okay. So when we say simplify, sometimes we want to do this. Sometimes it's as simple as just saying 5 because we know the square root of 25. If we don't know the square root of a number, then there's a chance it's not a perfect square. We just don't know it. We could always plug it in our calculator. If we get a decimal answer, then we know it's not a perfect square. So 24 was not a perfect square, and this is the way we try to simplify it. Now, look, some 30, 60, 90 triangles are super easy. What's half of 12? Half of 12 is 6, right? So to go from the hypotenuse to the short leg, we divide by 2. That's the rule that we figured out. And to go from the short leg to the long leg, we multiply by the square root of 3. So we just put down 6 square root of 3, and we leave it just like that. Now, sometimes you have a square root of 3 involved. Now, notice this is the 30-degree angle right here, right? So here is my short leg. This is my short leg. That's supposed to be an arrow right there. So this is my short leg over here. And to go from the short leg to the long leg, we multiply by the square root of 3. So let's see what would happen with this simplification. I get 13 square root of 3 times the square root of 3. Square root of 3 times square root of 3 is the same thing as the square root of 9. Okay, and the square root of 9, well, 9 is a perfect square. What times itself is equal to 9? 3. So this all becomes 13 times 3. 13 times 3 is 39. So that's the way we would simplify that one right there. Multiplying two square roots together gives us a square root of 9 right here. Square root of 3 times square root of 3, square root of 9. And the square root of 9 is 3. So 3 times 13 is 39. So we're going to look at how do you simplify some square roots today because they're involved in 30, 60, 90 triangles. Right? So your ALEKS assignment has some of those types of problems. Now, let me give myself a nice clean piece of paper here. All right. So how does the ALEKS assignment first start out? It starts out with a fraction, okay? And in the numerator, it'll have like the square root of 24. And in the denominator, it'll have something like the square root of 3. Where would this ever come up in a 30, 60, 90 triangle? Like, why do we want to know when we have a square root of 3 in the denominator? How would that situation ever happen? It doesn't happen on the problems that are pretty easy. And what I gave as an assignment to my pre-calc class was just a bunch of pretty straightforward, easy problems. So let me just show you real quick down here on number 7. Then we'll look at one that's a little bit more complicated. So we're looking at where would the square root of 3 ever end up in the denominator? Well, to go from the long leg to the short leg, we got to divide by the square root of 3. So I'm going to get 5 square root of 3 all over the square root of 3. But in this situation, square root of 3 divided by square root of 3 is just 1. So this side, the B side, is just 5 long. That's my answer, 5. Okay, it's not anything more complicated than that. That came out pretty easy. So remember what we're trying to do. We're trying to find one where you have the square root of 3 in the denominator. And so right over here, number 13, if you're going from the long leg, why is 36 the long leg? Because it's across from the 60-degree angle. So to go from the long leg to the short leg, we got to divide by the square root of 3. Let's zoom in on this guy. It's kind of small. It might be hard to see if you're watching this on your phone. So I get 36 divided by the square root of 3. Ooh, now this one is a little trickier. So sometimes we have to divide by the square root of 3. Now, let's look back at my first example here. If I had 24, like square root of 24 divided by square root of 3, I could think about that as just the square root of 24 divided by 3. Does 3 go into 24? It sure does. It goes in 8 times, right? So I'd write down the square root of 8. And like I was saying before, now this is really for more advanced. This is not our main lesson today. I mean, this is, I think, my final answer. I just leave it as square root of 8 for now. But for more advanced people, I want to remind you, like, we're always looking for factors that might simplify down. So 8 is the same thing as the square root of 4 times the square root of 2, or the square root of 8 is the same thing as square root of 4 times square root of 2. And the square root of 4, we know what that is. What times itself is 4? 4 is a perfect square. That means it's 2. So we get 2 square root of 2. So this is the way that would fully simplify. This one's completely simplified. Okay. And this one over here is partially simplified. We started out with something kind of complicated. We had a fraction, and we ended up with just, the square root of 8. So this is partly simplified. I'll put it that way. Partly simplified. Okay. All right. So that doesn't really explain one where you don't have, oops, I hit the wrong button there. You don't have, like, I can't divide square root of 3 into 36. So what do you do in that situation? How do you simplify that one? So in these situations where you have a square root in the denominator, our main goal is to not have a square root in the denominator. This is called rationalize the denominator. Right now it's an irrational number in the denominator. We're going to make it a rational number in the denominator. And here's the way you do it. You go 36 all over square root of 3. This is my original problem. I just made it a little bit bigger so I could see it. And then I'm going to multiply by the square root of 3 all over the square root of 3. All right. Now, you might say, what the heck's going on here? This looks kind of complicated. This is equivalent to 1. It equals 1, right? So look, if we multiply by 1, we're not going to change the value of the fraction. We're going to change the way the fraction looks. So what happens here? I get 36 times the square root of 3, because when you multiply fractions, it's super easy. You multiply numerator times numerator and denominator times denominator. So square root of 3 times square root of 3 is the square root of 9, because when you have positive numbers underneath the square root of sign, you can just multiply them together. Square root of 9 is 3. So now we're down to 36 square root of 3 all over 3. And look, I can divide the 3 into 36, and I get 12. So I get 12 square root of 3. So this is the kind of thing that we're going to do on the second part of the ALEKS assignment. We're going to rationalize the denominator. On the first part of the ALEKS assignment, all we're doing is we're trying to simplify by dividing by whatever is in the denominator, which in, I think, all the problems, the first 5 problems, you can just divide like the 3 into the 24. It comes out to square root of 8. I want you to see if you could break it into 2 factors. And if you can break it into 2 factors and one of them is a perfect square, then you can simplify further. Break into 2 factors where one is a perfect square, where one of them is a perfect square. If you can't find a factor that's a perfect square, then you don't do anything at all. You just leave it like as the square root of 8. Okay, so that's the first part of the assignment. How do you simplify a fraction like this? The second part of the assignment is how do you rationalize the denominator? Okay, so this part is called rationalize the denominator. All right, I hope I made that clear. Good luck.